So in this video, we're going to go over graphing quadratic functions in standard form. So just to remember what standard form is of a quadratic, that's going to be ax squared plus bx plus c. Ax squared plus bx plus c. A is doing the same thing to our quadratic function like A did for any in graph translation theorem where A dilates. A is telling you whether or not it's a reflection across the x-axis or not, okay, based on whether A is greater than 0 or less than 0. Now for A, B, and C, they're all going to be real numbers. A cannot be 0. If A was 0, it would make this term 0, and so you would not have a quadratic term. If you did not have a quadratic term, what you've got right here is a linear function. So having this term is what now makes it a quadratic function, okay? We know what the basic quadratic function looks like. So I'm just going to draw a quadratic function here. Here's our quadratic function, and every quadratic function has what's called an axis of symmetry. It is a vertical line, right? That's the axis of symmetry, okay? It's a vertical line that intersects with the vertex. So here's our vertex here. We know that when we have x coordinates that are equidistant from the axis of symmetry, their outputs are the same. And the reason that we don't have a v is because we do not have a constant rate of change. As x increases by 1, y does not constantly increase by the same value. Okay, it grows. So what we're going to do in graphing quadratic functions in standard form, okay, what you need to do is graph the axis of symmetry, the vertex, okay? Then you're going to want 4 more points. So you're going to have to make a table of values with 5 values in it, and you also should be able to name what the Y-intercept is. So in standard form, this is solely in standard form. To find the axis of symmetry, okay, it's the vertical line that intersects with the vertex. It creates symmetry, okay? So to find the axis of symmetry, the reason we write x equals is because it's a constant line, okay? It's a constant value for x. It creates a vertical line. This isn't saying the x coordinate is blank. This is saying this is going to be a vertical line, x equals blank. That's a vertical line, and it's going to be found by taking b and a and doing this formula, negative b over 2a. So a, b, and c are important, okay? To find the axis of symmetry, we have to do negative b over 2a. Then, if we want to get the vertex, okay, so we know the axis of symmetry, this line right here, is the line x equals negative b over 2a. I just didn't put parentheses here, okay? This is constant x. No matter what, where my finger is on this vertical line, x is always going to be the exact same value. If this was x equals 1, no matter where I am on this line, x will always be 1. So the vertex, the coordinates of the vertex, okay, the vertex's x coordinate has to be whatever the value of this constant line is. So it has to be negative b over 2a. It doesn't have a choice. It's going to fall on this line, has to have that value. Now to figure out what the y coordinate of the vertex is, all you have to do is plug in this x value and evaluate. So when you're in standard form, you need to make sure first thing you do is you grab the axis of symmetry and you grab the vertex. Okay? Then what we're going to do is just make a table of values. You're going to have 5 points, and then if you haven't already grabbed the Y-intercept, you're going to grab the Y-intercept, and that's how you're going to make your sketch, okay? So let's get started. I'll leave up here in the corner the formula for the axis of symmetry. Okay, so I'm going to graph each. So we want to make sure that we state the axis of symmetry. We want to state what the vertex is. Okay, we want to state what the domain and range is, Y-intercept. And we want these to be accurate sketches. When we did graph translation theorem, okay, our quadratic functions were not accurate, I shouldn't say accurate, but they were just rough sketches. We want much more detail here. So we'll do f of x equals negative x squared plus 2x plus 5. Okay, so we can see we're in standard form. So the first thing we're going to want to grab is the axis of symmetry. AOS just means axis of symmetry. It's the vertical line, so that's why it's x equals negative b over 2a. So we have to identify what a is and what b is. B is 2, a is negative 1, so this is going to be negative 2 over 2 times negative 1. That's negative 2 over negative 2, that's 1. So the axis of symmetry is x equals 1. You need to write that down, okay? You need to write down the equation of the axis of symmetry. Not only are you going to have it on your graph, you need to write its equation down. I need to know the equation of the axis of symmetry. This is the equation of the axis of symmetry. Your vertex, okay? The x-coordinate has to fall, right? The vertex intersects with the axis of symmetry. If x has to equal 1, then the vertex has to have an x-coordinate of 1. Now plug in 1. Please make sure you are following your proper algebra rules here, okay? When you compute, when you're plugging values in, you're following order of operations, you're squaring before you're multiplying by that negative 1. So this is going to be negative 1 plus 2 plus 5, so this is going to be 6. So your vertex is 1, 6. Now the a value is just like the a value in graph translation theorem. If a is greater than 0, okay? From the parent, you're not changing the reflection up and down. If a is less than 0, you're reflecting over the x-axis. So we could see that a is negative 1 here, so instead of it being a u facing up, we're going to have a u facing down. Next thing we want before we start plotting this, okay, we want to make our table of values. If you want to begin, you can begin by if you want to. You can draw the axis of symmetry. You can do this as you go if you'd like, okay? And then 1, 6. That's the vertex. Okay, I already knew I drew the graph just like this because I know it's going to be facing down. So we need 2 points that would fall to the left of the vertex. So that's going to be 0 and negative 1 values for the x-coordinates. And for to the right of the vertex, 2 and 3. You could pick any 2 points that would be on the left side, any 2 points that would be on the right side. Now remember, we see symmetry in coordinates, okay, that are y-coordinates. Well, we see symmetry in the graph. Our outputs are going to be the same if we're equidistant from the vertex. So is 0 and 2 equidistant? Yes. Is negative 1 and 3 equidistant? Yes. So that means that they're going to have the same output, which means we have a little bit less work here to do in our table of values. So we've got to plug negative 1 in. So that's going to be negative 1 squared plus 2 times negative 1 plus 5. So that's going to be negative 1 minus 2 plus 5. So that's going to be negative 3 plus 5. That's going to give us 2. We plug in 0, negative 0 squared plus 2 times 0 plus 5. 0 plus 5, that's 5. 2 and 0 are equidistant from the vertex, so the outputs have to be the same. 3 and negative 1 are the same, so that has to have the same output too. And so now we can finish our points here. And do your best, okay? And I also said we're going to name the y-intercept. The y-intercept, if you wanted to write it right below the table, you can. The y-intercept is the value of x. I'm sorry, the value of y when x is 0. So in standard form, it's going to be your c value. So our y-intercept is going to be, what is the value of y when x is 0, right? X is 0 on your y-axis. You'll see when we start doing modeling problems why it's so important. It's 5. We already actually have our y-intercept in our table. 0, 5. I want you to get in the habit of writing a y-intercept as the actual coordinate point 0, 5. All right, and the last thing, what's the domain? Domain of a quadratic is always all real numbers unless you had a specific domain restriction given to you. And your range, you will not be able to produce all real numbers for your range. That is because of what's happening. You're taking a number and raising it to an even power. So the largest y value comes from the vertex, and then all of our y coordinates are less. So this is going to be y is less than or equal to 6. Okay, so this is how we graph in standard form. Okay, we'll do 2 more examples. Okay, so we've got y equals 1/4 x squared minus x minus 3. I just put a y there, that's okay. It's identifying that it's the output when you plug in x. So we can see that we are in standard form. And so we are going to get the axis of symmetry. So what we're going to do is x equals negative b over 2a. I put parentheses around the inputs just so I don't make a mistake. So a is 1/4 and b is -1. So this is going to be -1 over 2 times 1/4. So this is going to be 1 over 2 times 1/4. That's going to be 2/4. That's going to be 1 divided by 1/2. It's going to be 1 times 2 over 1. So our axis of symmetry is going to be x equals 2. Okay, so our vertex, we know it has to have an x coordinate of 2, it has to match, plug in 2, 1/4 times 2 squared minus 2 minus 3. So if you want to take a calculator out and do this computation, you can, or you just do it by hand. You can do these computations by hand, just make sure you're writing down first what you're putting into your calculator. So this is going to give us 4. 4 times 1/4 is 1, minus 2 minus 3. That's going to give us -4. So the vertex is 2, -4. And I'm going to plug in 0, 1, 3, 4. Now 1 and 3 are equidistant from 2. So that means we're going to get the same outputs. 0 and 4 are equidistant. We're going to get the same outputs. So this is going to be 1/4 times 0 squared minus 0 minus 3. That's going to give us -3, so input 4 will also get an output of -3. Plug in 1, 1/4 times 1 squared minus 1 minus 3. So that's going to give us 1/4 minus 1 minus 3. That's going to give us 1/4 minus 4. And that's going to give us -3.75. You can use decimals in your outputs. Okay. So, now we start sketching. I'll put the axis of symmetry in first, and we know the vertex is going to intersect with that, and the vertex is at, let's see, 2, -4, and then we have 0, -3, and we have 1, -3.75. And so this one's a little wider. That's because a is, the absolute value of a is less than 1. It's 1/4. And the y-intercept, plug in 0 for x, and we actually have that in our table. The y-intercept here, okay, 1/4 times 0 squared minus 0 minus 3. You don't have to do it again if you already have it in your table, right? You actually already plugged in 0. Gives you -3. Y-intercept is the point 0, -3. The domain here is all real numbers. The range, you can either look at the graph. Okay, looking at the graph, we can see the minimum y values at the vertex, and then it's everything going up. So this is y is greater than or equal to -4. Or you could look at your table, your vertex, the y coordinate is either going to be the maximum value or the minimum value. You look at all of the other y's in your table, they're all greater than -4, therefore -4 is the minimum value. Okay, so here is number 2. Okay, let's do number 3, and if we might not have to do another one, however, although I said we're only going to do 3, we might have to do 4 problems. Let's see. All right, so number 3, we have y equals, let's do -2/3 x squared plus 1, okay? So if you notice, okay, it only has 2 terms. This is still standard form because you have no parentheses here where you have to distribute any terms, so you're seeing all your terms. If this confuses you, this is the same as -2/3 x plus 0x plus 1. So just because this is in the second spot here does not mean that this is b. b belongs with the linear, b is the coefficient on the linear term. A is the coefficient on the quadratic term. C is the constant term. So for this problem, A is -2/3, B is 0, and C is 1. Okay? So when we grab the axis of symmetry, that's going to be x equals -b over 2 times A. So that's going to be -0 over 2 times -2/3. So that's going to be 0 over some number, right? -4/3. We know 0 divided by any number, as long as it's not 0, is 0. So the axis of symmetry is x equals 0. If you do not have the linear term, b is 0. And if the expression is x equals -b over 2a, if you know you have a quadratic, a can't be 0, so you're always going to have 0 over some number that's not 0. So your axis of symmetry will always actually be x equals 0. So if we want to grab the vertex, okay, we know the x-coordinate has to be 0. So we plug in 0, -2/3 times 0 squared plus 1. That gives us 1. Okay, make a table of values. 0, 1 goes in the middle. -1, -2, 1, 2. -1 and 1 are equidistant. Okay, 2 and -2 are equidistant, so we only have to do this 2 times. So we plug in -2, so -2/3 times -2 squared plus 1. That's going to be -2/3 times 4 plus 1. That's going to be -8/3 plus 3/3 is -5/3. Okay, so that's going to be -1 and 2/3. You do not need to write these as fractions. You can put this right in your calculator and get the decimal, okay? So -1.667. Then plug in -1, so -2/3. Whoops, sorry. 2 has the same value, output value. -2/3 times -1 squared plus 1. -1 squared is 1. It's going to give us -2/3 plus 1. That's going to give us a third. 1 has the same output. Okay. X-axis, y-axis. Each tick mark is 1 unit. So our axis of symmetry is x equals 0, which is the y-axis. 0, 1. 1, comma 1/3, -1, 1/3. 2, -1 and 2/3, -2, -1 and 2/3. Okay. And our y-intercept, what's the value of y when x is 0? Well, we actually already know that because that's our vertex. Let's say you forgot it, just plug it back in. Okay, right as a coordinate point 0, 1. So the vertex can be the y-intercept, okay? And the last thing we have to do here, what's the domain? Domain is all real numbers. What's the range here? Range is y is, it's going down. That means if we look at our table, the y-coordinate of the vertex is larger than all of the other points. That means it's the maximum value that your quadratic can actually output, and every other output will be less than that. Okay, y is less than or equal to 1. And we're going to do one more problem. Okay, y equals 5x squared plus 7x. So this is a quadratic function in standard form, even though there are only two terms up there. This is still standard form. C is just 0, A is 5, B is 7, okay, and C is 0. So we grab our axis of symmetry. That's going to be the vertical line, x equals negative b over 2a. And that's going to be negative 7 over 2 times 5. So that's going to be negative 7/10. Okay? So what I want you to do is I want you to keep your vertex exact. So I want you to keep your axis of symmetry exact. So your axis of symmetry is x equals negative 7/10. Okay, our vertex is going to have an x coordinate of negative 7/10. Now here it would just be negative 0.7, but let's say it was 1/3. I don't want you writing 0.3 because there's something very important about the vertex. And if you didn't have it exact, it would not give you a characteristic that we'll talk about in the future. Okay? It wouldn't give you specifically what the y coordinate is, and it needs to give you that exactly. Okay? So negative 7/10 we're going to plug in. That's going to be 5 times negative 7/10 squared plus 7 times negative 7/10. Now I just want this, I want the vertex exact, okay? So we're going to do this by hand, but in the table you can round everything in your table, okay? So this is going to be 5 times 49 over 100 plus, whoops, that's a negative 7/10, okay? Sorry about that. Negative 7/10, so that's going to be plus negative 49/10. So 49 times 5, that's going to be 250 minus 5, so it's going to be 245 over 100 minus 49/10. So we need to get a common denominator. We're going to have to multiply that by 10 over 10. So that's going to give us 490. So this is going to be 245 minus 490 puts us at negative 245 over 100. Okay, we can divide that by 5. 245 divided by 5 puts us at 49. So negative 49, 100 divided by 5 puts us at 20. Can't simplify that any further. So the vertex is negative 49 over 20. So now we make our table of values. This is the only piece that I want exact. Axis of symmetry and vertex. Okay, please make sure that it's exact. In your table, if you want to round, go ahead and round. That way you, when you're picking points and when you're graphing, it's easier to think of negative 49 over 20 as a decimal than to try and plot that. So negative 7/10 is going to be negative 0.7. And negative 49 divided by 20 is going to be negative 2.45. Okay? Both of these are exact, so we didn't actually round anything here. We just wrote them as decimals. Now, in your table, you do not need to try and pick values so that you are equidistant from the vertex. It just means your points aren't going to share the same outputs. That's perfectly fine. But as long as you have 2 points that fall to the left of the vertex and 2 points that fall to the right, that's all that matters. So points that would fall to the left, okay, so that means the next coordinate has to be less than negative 0.7, so that would be negative 1 and negative 2. I wouldn't pick decimal values because it's just more work to put into your calculator, okay? I'm going to do these, they can be done by hand probably, just because we don't have any fractional values there, but if they were a fraction, you might want to just put it right into your calculator. Okay, so 1 is greater than negative 0.7. None of these have the same outputs because none of them are equidistant from the vertex. So 5 times negative 2 squared plus 7 times negative 2. That's going to be 5 times 4 minus 14. So that's going to be 20 minus 14, so that's going to give me 6. Okay, 5 times negative 1 squared plus 7 times negative 1. That's going to be 5 minus 7. That's going to be negative 2. Plug in 0. 5 times 0 squared plus 7 times 0. That's going to be 0. plug in 1, 5 times 1 squared plus 7 times 1. That's going to be 5 plus 7, that's going to give me 12. Okay, so now we just make our graph. Seven, 8, 9, 10, 11, 12. Okay, so 1 is 12, 0 is 0, negative 0.7 is negative 2.45, negative 1 is negative 2, and negative 2 is 1, 2, 3, 4, 5, 6. Now, don't get confused and say to yourself, how come 1 is 12 and negative 2 is 6? Well, negative 0.7, okay, is 1.7 units away from the input of 1. So that means that it's got more time to grow than negative 2 because negative 2 is only 1.3 units away. Okay? So make that curvature, and you know what your y-intercept is actually because one of your points in your table is when x equals 0, but if you're not sure, oops, not negative 5, 5 times 0 squared plus 7 times 0. That gives you 0 plus 0 gives you 0. Okay, the domain and the range. Domain is always all reals unless you have a specified domain restriction, and your range. So we look, is negative 2.45 in your table the greatest value or the smallest? It is the smallest, so that means it's what's called the minimum y value, the minimum, and every other coordinate has a y that's greater than that, so y is greater than or equal to negative 2.45 or negative 49/20. Okay, and so that is it for graphing in standard form. Make sure you identify the axis of symmetry, the vertex, have 5 points, have your graph, have the domain and range, know about getting your y-intercept when you're in standard form. And when you label your vertex, please make sure it is exact, and then in your table you can be rounding.